Decomposing fractions into partial fractions, Part 3. Mix examples. In this first example, we see that the denominator has already been fully factorized, since x squared plus 1 cannot be factorized into linear factors. The factor x is repeated 3 times, the factor x squared plus 1 is repeated once, and the factor x plus 2 is repeated twice, and this means we can decompose this fraction into 6 parts. The first 3 fractions will have denominators x, x squared, and x cubed, and since x is linear, the numerators must be a constant in each case, a, b, and c. Next we'll have a fraction with denominator x squared plus 1, and since x squared plus 1 is a second degree expression, the numerator must be a first degree expression, say dx plus e. The last 2 fractions will consist of a fraction with denominator x plus 2 and a fraction with denominator x plus 2 squared. Since x plus 2 is linear again, the numerators of each of these fractions must be constants, say f and g. In the last example, we see again that the numerator has been completely factorized, since x squared plus 9 and x squared plus 4 cannot be factorized into linear factors. The factor 2x minus 1 has been repeated once, the factor x squared plus 9 has been repeated once, the factor x plus 1 has been repeated twice, and the factor x squared plus 4 has been repeated 3 times, meaning that this fraction can be decomposed into 7 parts. The first fraction will have the denominator 2x minus 1, and since this is a linear expression, the numerator will be a constant, say a. The next fraction has denominator x squared plus 9. And since x squared plus 9 is a second degree expression, the numerator must be a first degree expression, say bx plus c. Since x plus 1 is repeated twice, the next 2 fractions will have denominators x plus 1 and x plus 1 squared. Since x plus 1 is linear, the numerators must be constants, say d and e. Lastly, we see that x squared plus 4 has been repeated 3 times, resulting in 3 fractions with denominators x squared plus 4, x squared plus 4 squared, and x squared plus 4 cubed. Since x squared plus 4 is an expression of the second degree, the numerators must be first degree expressions, say fx plus g, hx plus j, and kx plus m. In the next video, we'll see how to find the values of a, b, and c, etc.